All right, so today we're going to do a lesson today on quadrilaterals. All right, so tune into this video. Hope you enjoy. Let's go.
In this video is give an overview of quadrilaterals, and you can imagine from this prefix, or I guess you could say the beginning of this word quad, this involves four of something, and
Quad means
quadrilaterals, as you can imagine, are shapes, and we're going to be talking about two-dimensional shapes that have four sides and four vertices and four angles. So, for example, 1, 2, 3, 4. That is a quadrilateral. The last side is two straight. 1, 2, 3, 4. That is a quadrilateral. 1, 2, 3, 4. These are all quadrilaterals. They all have four sides, four vertices, and clearly four angles. One angle, two angles, three angles, and four angles. Here you can measure. Actually, let me draw this one a little bit bigger because it's interesting.
so one thing that I want to point out to you guys real quick. Again, quad means four. That means that they have four sides, four vertices, and four angles. So you can see it. So these right here, like he's pointing to, represent our so 1, 2, 3, 4. Those represent the four
So this
angles.
one right over
Oh, sorry, let me
here.
pause that again. It also has four sides. 1, 2, 3, 4. And where any two lines connect, so this line right here and this line connects right here, they make these little points right here, which we call vertices.
You have one angle, two angles, three angle, and then you have this really big angle right over there. If you look at the interior angles of this quadrilateral. Now, quadrilaterals, as you can imagine, can be subdivided into other groups based on the properties of the quadrilaterals. And the main subdivision of quadrilaterals is between concave and convex quadrilaterals. So you have concave and you have convex. And the way I remember concave quadrilaterals, or really concave polygons of any number of shapes, is that it looks like something is caved in. So for example, this is a concave quadrilateral. It looks like this side has been caved in. And one way to define concave quadrilaterals, so let me draw it a little bit bigger. So this right over here is a concave quadrilateral, is that it has an interior angle that is larger than 180 degrees. So for example, this interior angle right over here is larger than 180 degrees.
That makes
It's an
sense.
interesting proof. Maybe I'll do a video section of a pretty simple proof to show that if you have a concave quadrilateral, at least one of the interior angles has a measure larger than 180 degrees, that none of the sides can be parallel to each other. The other type of quadrilateral you can imagine is when all of the interior angles are less than 180 degrees. And you might say, wait, what happens at 180 degrees? Well, if this angle was 180 degrees, then these wouldn't be two different sides. It would just be one side, and that would look like a
Ah,
triangle. But if all of the interior angles are less than 180 degrees, then you are dealing with a convex quadrilateral. So this convex quadrilateral would involve that one and that one over there. So this right over here is what a convex quadrilateral. This is what a convex quadrilateral would look like. Four points, four sides, four angles. Now within convex quadrilaterals, there are some other interesting categorizations. So now we're just going to focus on convex quadrilaterals. So that's going to be all of this space over here. So one type of convex quadrilateral is a trapezoid.
so we know that the first way that we can classify quadrilaterals is as concave and convex. Just to review, concave means that it has one interior angle that is more than 180 degrees, like we saw in this one, and convex means all of the angles are less than 90 degrees. So we see 1, 2, 3, 4. All right, so just wanted to recap right that. If you're taking notes, you should be putting that in your notes right now. That's the first way we can classify.
A trapezoid. And a trapezoid is a convex quadrilateral, and sometimes the definition here is a little bit different. People will use different definitions. So some people will say a trapezoid is a quadrilateral that has exactly two sides that are parallel to each other. So for example, they would say that this right over here is a trapezoid where this side is parallel to that side. If I give it some letters here, if I call this trapezoid A, B, C,
C,
D,
D.
we
Got it.
could say that segment AB is parallel to segment DC, and because of that, we know that that this is a trapezoid. Now I said that the definition is a little fuzzy because some people say you can have exactly one pair of parallel sides, but some people say at least one pair of parallel sides. So if you use the original definition, and that's the kind of thing that most people are referring to when they say a trapezoid, exactly one pair of parallel sides, it might be something like this. But if you use the broader definition of at least one pair of parallel sides, then maybe this could also be considered a trapezoid. So you have one pair of parallel sides like that, and then you have another pair of parallel sides like that. So this is a question mark where it comes to a trapezoid. A trapezoid is definitely this thing here where you have exactly one pair of parallel sides. Depending on people's definition, this may or may not be a trapezoid. If you say it's exactly one pair of parallel sides, this is not a trapezoid because it has two pairs. If you say at least one pair of parallel sides, then this is a trapezoid. So I'll put that in a question mark there. But there is a name for this, regardless of your definition of what a trapezoid is. If you have a quadrilateral with two pairs of parallel sides, you are then dealing with a parallelogram. So the one thing that you definitely can call this is a parallelogram. Parallel.
Again, see in the word parallelogram, you see parallel. So a parallelogram has two sets, again, of equal or parallel sides.
Parallelogram. And I'll just draw it a little bit bigger. So it's a quadrilateral. If I have a quadrilateral, and if I have two pairs of parallel sides, so two or the opposite sides are parallel, so that side is parallel to that side, and then this side is parallel to that side there, you're dealing with a parallelogram. And then parallelograms can be subdivided even further. They can be subdivided even further. If the four angles in a parallelogram are all right angles, you're dealing with a rectangle. So let me draw one like that. So if the four sides, so from parallelograms, this is all in the parallelogram universe. What I'm drawing right over here, this is all the parallelogram universe. So this parallelogram tells me that opposite sides are parallel. And then if we know that all four angles are 90 degrees, and we've proven in previous videos how to figure out the sum of the interior angles of any polygon, using the same method, you can say that the sum of the interior angles of a rectangle or any quadrilateral is actually 360 degrees. And you see that in this special case as well, but maybe we'll prove it in a separate video. But this right over here we would call a rectangle. Parallelogram, opposite sides parallel, and we have four right angles. Now, if we have a parallelogram where we don't necessarily have four right angles, but we do have the length of all the sides be equal, then we're dealing with a rhombus. So let me draw it like that. So it's a parallelogram. This is a parallelogram. So that side is parallel to that side. This side is parallel to that side. And we also know that all four sides have equal length. So this side's length is equal to that side's length, which is equal to that side's length, which is equal to that side's length. Then we are dealing with a rhombus.
One thing I want you guys to notice is these different things that they use to explain that the sides are equal or congruent. So again, so when they use parallel, they use these symbols right here. When they do the angles, they use these boxes right here. And what we just saw with equal sides, the lengths of each side, they use these little lines or dashes. So these are the three things that I will be looking for you guys to use to show, again, if they are parallel, if they have equal angles, or if they have equal sides, you can use these slashes right here.
So one way to view it, all rhombi are parallelograms, all rectangles are parallelograms. All parallelograms you cannot assume to be rectangles. All parallelograms you cannot assume to be rhombi. Now, something can be both a rectangle and a rhombus. So let's say that this is the universe of rectangles. So the universe of rectangles, a little bit of a Venn diagram here, is that set of shapes. And the universe of rhombi is this set of shapes right over here. So what would it look like? Well, you would have four right angles, and they would all have the same length. So it would look like this. So it would definitely be a parallelogram. It would be a parallelogram, four right angles, and all the sides would have the same length. And this is probably the first of the shapes that you learned, or one of the first shapes. This is clearly a square. So all squares are both rhombi, are members of they can also be considered a rhombus, and they can also be considered a rectangle, and they can also be considered a parallelogram. But clearly, not all rectangles are squares, or definitely not all parallelograms are squares. This one clearly right over here is neither a rectangle nor a rhombi nor a square. So that's an overview. Just gives you a little bit of taxonomy of quadrilaterals.
All right, so hopefully you enjoyed that lesson. Again, that's just a brief understanding of quadrilaterals, quadra again meaning four, and different ways that we can classify them. All right, keep working hard. Peace.